Hi there! So in this video, we'll be discussing more about the ellipse and do more challenging examples in this video. So let's begin. So first, let us recall that from the previous video, we defined what an ellipse is. So again, an ellipse is the set of all points whose distances from two given fixed points sum up to a constant. We call these two fixed points the foci of the ellipse. In illustration, the foci here is f1 and f2, and the ellipse is this violet shape out here. To illustrate again the definition, suppose we have a point out here. If we obtain its distance to the first focus and the second focus, let's denote this by, let's say, d1 and d2. If we add d1 and d2, we will obtain a certain constant, let's say c. And then doing the same for this other one, let's say we have this point out here, and then we have this distance from the first focus to the second focus. Let us denote this by r1 and r2. If we add r1 and r2, then we must also obtain c. So that is what the definition of an ellipse is telling us. Aside from this, we also have more definitions related to it. So first is the center. It is the midpoint of the two foci. It is located out here. The vertices, it is the point of intersection of the line through the foci and the ellipse. The point of intersection is this v1 and v2. Then the major axis, the line segment whose endpoints are the vertices, this green line segment. And then minor axis is the perpendicular bisector of the major axis with endpoints on the ellipse. So it is this line out. It's important to remember these definitions, and moreover, it is important to understand their relationship. Like for instance, the major axis, take note that it contains v1, f1, c, f2, and v2, basically the foci, the vertices, and the center. Because of that, then the center, the vertices, and the foci are all in line. Also, take note that from the center, its distance to the first focus and the second focus must be the same, and the same goes for the vertices. Its distance from the first vertex to the second vertex must be the same. So it's important to take note of that later on. Good. Then we'll also discuss the equation of an ellipse. So given A to be larger than B and C given by this expression, then the equation of the ellipse can be of these two forms. The difference is dependent on where the larger denominator is. For this first case, the larger denominator is on the x variable, A, out here. And then for this next case, the larger denominator is on the y variable, out here. To illustrate how this denominator works, it basically tells us the largest width of an ellipse, horizontally and vertically. So for instance, in this first case, let's see, this is the first case. To illustrate it, see this one is HK, the center. Then A out here represents its distance along the horizontal line. It tells us that this distance must be A and this distance must be A as well. Since A here is the larger, then for the vertical part, we know that it must be smaller. Let's see, it's out here, there. So depending on the denominator, it tells the distance of that corresponding variable. So for instance, A here dictates the largest width of X along the X axis. So here and out here. And then for B, it represents the distance along the y-axis, or parallel to y-axis to be precise, and it's represented by this and this. That is why in this first case, the major axis is horizontal, since the larger width here is the horizontal line out here. That is why here the vertices is shifted from the center by changing the x-coordinate, and the same for the focus, so that the vertices is located here and the foci is located here. So same analogy applies for the other one. Take note that from this remark and from this illustration, we know that the minor axis is dependent on B, the smaller value. So that is how this formula works. If you just understand how A and B dictates the ellipse, it's easy to obtain the vertices, the focus, and so on. Okay, now that we have been able to refresh all the important concepts associated with the ellipse, we are now ready to go to our first example. So for our first example, our goal is to find the equation of the ellipse with center at the origin, foci at f1 given by 0, 3, and f2, 0, -3, and the major axis to be length 8 units. Okay, so how do we solve this? The first thing to do is to plot what we have. Based on the given, we know that the center is at the origin. That's why we have C out here. And the first focus is this. Let's say this one is 0, 3. And this next one is 0, -3. Given this, the first thing that we can obtain is actually the vertices. So take note that the vertices are given by 0, 4 and 0, -4. Why is that? Well, take note that we are also given that the major axis is of length 8 units. By definition, major axis is the line segment with endpoints at the vertices. In our illustration, given that idea, then we know that this length out here must be of 8 units. Moreover, we know that from the center, its distance to the first vertex and the second vertex must be the same, which means that 8 divided by 2 is 4. So this one must be of distance 4 and this one must be of distance 4 for that idea to work. That is how we obtain 4 out here. So this means that from the center, the origin, which we know to be 0, 0, we just add and subtract to its y coordinate 4 to obtain 0, 4 and 0, negative 4 out here. So given that, we know that A in our equation earlier is 4, and moreover, we also know that C is equal to 3. And how did we obtain that? Again, A here represents the distance that we add from the center to obtain the vertex. So as we have seen earlier, what we add is 4, and the same for this one at the bottom. And then C here is the one that we add to obtain the focus from the center. So this time, from the center, 0, 0, to obtain the first focus, we add 3. And we do the same for this one at the bottom. So that is how we obtained A equal to 4 and C equal to 3. And then using this formula, we know that C is equal to the square root of A squared minus B squared. We can obtain B squared. So take note what we are solving for B squared instead of B, since in the formula, all we need is just B squared. So solving for this equation, one can verify that B squared is equal to 7. So that is easy to verify. That's just 3 squared, or that's just 4 squared minus 3 squared, 16 minus 9, that's 7. And then once you have this, we are now ready to give out the equation of this ellipse. So by the formula, the equation of the ellipse is given by x squared over 7 plus y squared over 16 equal to 1. First, take note that here, since the center is 0, 0, we just have here x minus 0 squared or x squared and y minus 0 squared or y squared. And then take note that since the major axis here is vertical, based on how f1, f2 and v1, v2 was constructed, we know it is vertical. Then we know that the larger denominator, which in this case is 16, since 16 is 4 squared, so that's A, is on the y variable. And then the smaller value, which is b squared, b7, is on the x variable. That is how we have obtained the equation of the ellipse. So this problem is quite tricky, but as long as you know by heart the definition and the formulas, it becomes easier. Let's move on to the next one. So for this next one, our goal is to find the equation of the ellipse with foci at f1 given by 2, 0 and f2 given by 2, 12 and a vertex at 2, 14. So again, first step, plot what we have. So plotting what we have here the first focus, the second focus, and a vertex out here. So given this, what can we first obtain? Well, we can obtain the center. The center is given by 2, 6. And how did we obtain that? Well, just recall that the distance of the center from the first focus and the second focus must be equal. And how will we obtain that? If we obtain its midpoint. So you can use the midpoint formula to obtain 2, 6 using these foci, f1 and f2. Or an easier way to obtain that is just take note that to obtain its midpoint, take note that for the x coordinate, this does not change. So we still have 2 here. And then for the y coordinate, we just get the one in the middle. So 0, 12, in between that is 6. That's why we have 6 here. Okay, then once we have the center, what else can we obtain? Well, take note that the distance of the center to the first vertex must be equal to its distance from the second vertex. That's why the second vertex is given by 2, negative 2. So how did we obtain that one? Take note that, again, the center here is given by 2, 6. And then the first vertex is given by 2, 14. So we know that the distance out here to obtain this one is 8. Since we know that distance of center from the first vertex and the second vertex are the same, so this one must also be 8. So basically, instead of adding 8 to 6 to obtain 14, we instead subtract 8 from 6 to obtain 2, negative 2. And so we have this. So now that we have these, we can now easily obtain, like earlier, the A and the C. So the A in this case is 8. Since again, it is the distance from the center to the vertices. And then C is equal to 6, since it is the distance from the center to the foci. And then once you have that, again, we can easily obtain b, or b squared to be precise. So given the formula, just plug in a and c, solve for b squared, and one can verify that we will obtain b squared equal to 28. And then once you have that, we can easily construct now the equation of the ellipse. So by the formula, the equation of the ellipse is given by quantity x minus 2 squared and quantity y minus 6 squared out here, since the center is 2, 6. And for the denominators, take note that the major axis here is vertical, which means that the larger denominator must be on the y coordinate. The larger denominator is 64, since 64 is a squared or 8 squared. And then the smaller denominator is 28. It is put out here in the x coordinate. And so that answers the problem. So again, as you can see, the strategy here is quite similar to the first one, but instead of the center, we are instead given a vertex. So just to end this one, take note that I have a feedback form on the description or the comment section down below, so kindly help me provide better math content to you by answering the Google form in the description down below. So it's just a 3 question asking you what you liked about this video, what you disliked about it, or how you think I can improve on this one, and also what you like to see more in the future videos to help me cater my math content specifically on your needs in learning math. So if that is too hassle for you, you can just comment in the comment section down below and I'll be glad to read that. Yeah, that's it. I hope you enjoyed this one and have a nice day.